Alright, welcome back to another glorious day of properties with exponents. I'm Mr. Thornburg. I'm going to be your DJ today for the duration of the video. And let's go ahead and get started because we've got a lot to cover. Okay, so let's go back here to slide 1. Now, the big idea, multiplying powers with the same bases. Okay, so right off the bat, we got to get this idea of same base in our head whenever we're multiplying powers. So the big idea, I have 3 to the 4th and 3 to the 3rd. 3 is my base, because those are the base of the exponents. They are the same, so I can multiply them together. All you have to think, you know that exponents mean multiplication. It means I'm multiplying 3 threes together, or 4 threes together. 1, 2, 3, 4. And here I'm multiplying 3 threes together. 1, 2, 3. Easy enough. So how many total 3's am I multiplying together? Well, there's 4 here and 3 here. That's 7, which is logically equivalent to 4 plus 3, 7. 4 plus 3 is 7. Over here, I got 3 to the negative 2. Now, we learned the other day that a negative exponent actually means reciprocal. Okay, we learned the third function of negative signs, which is the reciprocal when we're talking about exponents. So this is actually 1/3 times 1/3, or 1 over 3 squared. So 1/3 times 1/3. And here I'm multiplying 5 threes together. Okay, so 3 times 3 times 3 times 3 times 3, 5. Okay. Well, these cancel when you have one on the top and bottom. They cancel together. So what am I left with? 3 threes. That's what I get. Or negative 2 plus 5 equals 3. Okay? General form, this is again just for any number a to m, any number a to n, and multiplication is involved, then we just write it as a to the m plus n. The key is being able to add and subtract exponents that the multiplied terms must have the same base. Again, that same base is big. Alright? So let's look at another one here. Let's look at a few examples. Again, same base. That's very important. They have the same base, so we could just write it as 7 5 plus 3, or 7 eighths. Here, still, same base. So this is x to the negative 11 plus 6, or, equals x to the negative 5. Don't leave that like that, which is 1 over x to the 5th. Reciprocal. Okay, same base, 6 to the negative 3 plus 5, which is 6 squared. Alright, and our final one, x, 4 plus 7 equals x to the 11th. Okay, pretty straightforward, pretty simple. Hopefully there's not much involved in that. That's multiplication. We add the exponents. Like bases multiplying, add the exponents. Okay, now we're getting into a little more of a complex situation. Okay, there's multiple bases going on in here, so I have to be really careful to make sure that I line these bases up. X's go with X's, Y's go with Y's, so we get Y to the 1 plus 2. Remember, there's always a 1 here. And X to the 2 plus 3, which brings my final answer. There's 5 X's that are being multiplied together, and there are 3 Y's that are being multiplied together. Over here, same thing. I got some X's, and I got some Y's that I'm going to put in a different color. Okay, my Y's are 3 plus a negative 2. Be careful there. And my X's are to the negative 2 plus 5, which makes my final answer x to the 3rd, y to the 1st. Okay? Now, complete each equation here. Okay, just follow the same path that we have been. Go ahead and hit pause on the video. Complete those 2 equations. Hit resume, and I'll show you the answers. Alright, hopefully you've paused and got through some of those. This one, 9 plus what gives me 16. Hopefully everybody put a 7. We're missing a 7 right here. So this should be a 7 to the 7th. Okay, here, I know I want to end up with y to the 6th. Well, this is y to the 1, so what plus 1 gives me 6? This better be a 5. I'm not going to try to squeeze it in there, so I'm just writing it below, put a little arrow. And then I don't have any x's over here, which means that really what I need is x to the 0 power. And again, 5 minus what gives me 0? And again, this one right here should be another 5. Okay? Pretty straightforward. Think you're going to enjoy your homework tomorrow, not because you enjoy homework, but just because you probably should get it done. Alright, let's look at one last thing. We need to talk about scientific notation. Scientific notation is used to show very big or small numbers and is in the form of a plus 10 to the b. Okay, where a is between, equal to, or greater than 1 but less than 10. Alright, so it's got to be a number between 1 and 10. Can be 1 but cannot be 10. It can never be 2 digits. Alright, so if we want to write the number in scientific notation, and we're going to use this form, a times 10 to the b. Well, if we're multiplying by powers of 10, then you know all we're doing is really moving this decimal place over here. Okay? There's 3, here's 4, there's 6, 7, 8, 9, 10. And we're going to move this decimal place over until we get a number that's between 1 and 10. If we move it to here, 4,326 is not. 43.26 is not. 4.326 absolutely is between 1 and 10. So we're going to use that number right there. So 4.326. Okay, that's my a. I just found a times 10 to some power. Well, the power that you're going to use is just how many times you had to move your decimal place. Alright? So I had to move my decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I had to move it 10 times. Okay? So the power that I'm going to use is 10. Alright? Now, the power that I'm going to use is also positive. Okay? We've got to make sure that we understand what the positive and the negative means here. A positive number means that the number is going to be a lot, well, not a lot, but it's going to be bigger than the number I'm using. It's going to be bigger than my a. Okay? So a positive exponent is going to create a bigger number. That's what we want, right? We want 43 billion. So to get that, I need a positive exponent. Alright? Now, the opposite is true for number 10. Number 10, I'm still starting the same way. I'm going to count over by decimal points until I get a number that's between 1 and 10. 4.1 will work. 4.1 is between 1 and 10. Following my format, times 10 to the what? Well, again, we go right back to the beginning. Let's count. 1, 2, 3, 4, 5. Okay, so it's to the 5th power. But I want a number that's a lot smaller than 4.1. And if you want a number that's a lot smaller than 4.1, hopefully, thinking back to what we learned about, I believe it was on Monday, you know this has got to be negative. It's got to be negative. Smaller number, bigger number. The same can be true as if we write it in standard form. To write these in standard form, I got 8.2. And then I'm going to move 3 decimal places. 1, 2, 3. It's a positive 3, so I want a bigger number. My final answer is going to be 8, 2. Wherever I don't have a spot, let's put in a 0. Or wherever I don't have a digit, but there is a spot, let's put in a 0. So this is my final number here. Number 12, we have 3.71 times 10 to the negative 7th. Okay? So again, I want a smaller number. So if I go this way, the number's getting bigger, right? But I want a smaller number. So we're going to move back this way. 1, 2, 3, 4, 5, 6, 7. Hopefully, your spaces are a little bit clearer than mine. I am struggling. All right. 0, 0, 0, 0, 0, 0. Okay, so I have all these zeros. You know the decimal place goes right here. So the actual number is 0.000. 0, 0, 0, 3, 7, 1. Okay? That is your actual number. So it's really just keeping track of your decimal place. I mean, that's both ways. Just keep track of your decimal place and you'll be fine. Alright, last thing. Multiply and write in scientific notation. Again, we know that we can only really do stuff with like bases. So this one is going to be 4 times 2 times 10 to the 3rd 10 to the 5th. Okay? Notice where I got all that from. Here's this. That's where that came from. And here's this. That's where that came from. Now, go ahead and finish this off. 4 times 2 is 8. That's good. We're still between 1 and 10, so I'm okay. I don't have to move any decimal places. 3 plus 5, because they are like bases, is 10 to the 8th. All right. Doing the same thing here. Hopefully you're starting to pick up on this. I got my 6 and my 7, so 6 times 7 times, and over here I have my 10 to the negative 5th and 10 to the 8th, so 10 to the negative 5 plus 8. All right. 6 times 7 is 42. Uh-oh, got a little bit of an issue there. Times 10 to the 3rd, just adding those together. 42 is not between 1 and 10, so let's go ahead and move this decimal place over here. We'll turn it into 4.2 times 10 to the 4th. Make sure that grows. We move the decimal place. Everything is satisfied right now. Go ahead and do number 15, and we'll check it over tomorrow. We're kind of running late. I want to stop you, and I want to keep this around 11 minutes. Just ran a little bit over, all right? So we'll go through this tomorrow. Make sure you answer your question. I'll talk to you later. Bye.